Hello, good morning. Can you hear me?
Sir, good morning.
Sir, morning, sir. So, shall we start?
Sir, we can start.
Okay. Fine. Guys, so today we are going to start, like we discussed last class, that we will be starting chemical kinetics today. Okay. So, yeah. So, we'll start chemical kinetics. Okay. So, guys, this chapter, chemical kinetics, is a very important chapter of grade 12. Okay, whether you're going to write board exam or any competitive exam, at least you're going to have one question from this chapter. Okay, whether it is JE, Comet K, BitSat, KCET, whatever exam you'll write, even in Comet K, KCET, BitSat, you'll get more than one question from this. But one question in JE, definitely you're going to have from this chapter. Okay, so that's why it's very important chapter. Okay, for your grade 12. Second thing, it's more like mathematics. This chapter is all about integration and differentiation. Okay, we have huge application of integration over here, right? Mathematical equation you will get, based on that you will get some questions, numerical questions. Okay, so it's a different chapter from the other chapter that we have in chemistry, where we have theoretical stuff which we have to understand, and then some questions based on that we'll get. Okay, this is more about the application of integration. That's the difference we have here. Okay, now first of all, if you talk about chemical reactions, correct? So chemistry is all about chemical reaction, right? So if I talk about chemical reactions, so what all chapter we have discussed regarding this chemical reaction mainly? So if we talk about this chemical reaction, we have already studied two different chapters, and that is thermodynamics in grade 11, thermodynamics, and we have studied about chemical equilibrium. Chemical equilibrium. Okay, we are trying to understand what is this chapter all about, chemical kinetics, and what we are going to study in this chapter. Okay, so thermodynamics we have studied about. We have studied about what? We have studied about feasibility of a reaction. Okay, feasibility means under a given condition, given set of condition, whether the reaction is possible or not. That is the feasibility of reaction. Okay, in chemical equilibrium, we have discussed about the direction of reaction. Means what? In which direction the reaction proceeds, whether it is forward or backward. That is what we have discussed about, forward or backward. So we deal with the direction of reaction. Okay. Feasibility of reaction means what? Like I said, under a given set of condition, whether a reaction is feasible or not. And what is the condition for the feasibility of reaction? Delta G is less than 0. Okay, so these two things we have already understood, right? Feasibility and direction of reaction. Now, if you assume, suppose if I ask you one question here, right? And the question is, suppose if I write down one reaction, N2 plus 3H2 gives 2NH3, right? And if you suppose if you know the number of moles, we have A moles of N2, B moles of H2, like this number of moles you know. And if I ask you, the time required to finish or complete this reaction. Time required to finish or complete this reaction, or if I ask you the speed with which the reaction is proceeding. Okay, so what is your answer? If I ask you here, suppose a condition is given, if I ask you that whether the reaction is feasible or not, you can answer this question by calculating delta G. If it is less than 0 at the given condition, then you can say yes, reaction is feasible. Direction of reaction, I can ask, you can also tell me under a given set of condition whether the reaction goes in forward direction or backward direction. Okay, but with what speed the reaction is proceeding or by what time the reaction gets over, right? This information we do not have right now. Okay, you cannot answer this question because we do not know the rate at which the reaction is proceeding. Okay, you can think about it. You cannot answer these two questions here. Rate means what? Rate is nothing but speed. Rate, if you define rate, is anything that is calculated per unit time. Like for example, if I ask you what is acceleration, acceleration is velocity per unit time, rate of change in velocity, right? Rate of change in speed is what? Is sorry, rate of change in distance is speed, rate of change in displacement is velocity, rate of change in velocity is acceleration. Now, all these definition, if you see, we always divide by time. Distance by time is velocity, right? Distance per unit time, rate, velocity, sorry, speed. Displacement per unit time, velocity, right? Again, you see rate. Displacement per unit time, rate, okay? Velocity per unit time, acceleration, right? And that is what we say, we say rate of change of displacement is velocity, rate of change of distance, speed, rate of change of velocity, acceleration. So all these terms, if you see, we have rate and per unit time calculation is there, right? The rate, whenever we say, it means per unit time calculation, we have to understand, correct? Now, this information, by what time the reaction gets over and with what speed the reaction is proceeding, this information, or we can answer this question once we study the chapter called chemical kinetics. You understood this fact, what we are going to do in this chapter? All of you?
Yes, sir.
Right?
So,
So we are going to start, basically we are going to understand the rate of a reaction. Basic thing is that, okay? So chemical kinetics is what? Chemical kinetics, it is the branch of physical chemistry that deals with the rate of a chemical reaction, okay? Chemical kinetics branch of physical chemistry that deals with the rate of reaction. Going forward, rate of reaction, we'll use this abbreviation for rate of reaction. Okay. It also explains the factor affecting rate and the mechanism of chemical reaction. Okay, so mechanism of chemical reaction we'll discuss again here, and what all factors which affects the rate of a reaction. Okay, now if you talk about the speed or rate at which the reaction is proceeding, okay, so speed of a reaction or rate of a reaction. If you talk about the speed of a reaction, then the chemical reaction is classified into three categories here. Chemical reaction is classified into three categories. Okay. The first one is very fast, or we also call it as instantaneous reaction. Very fast or instantaneous reaction. The second one is just opposite of it, very slow reaction. And third one is the reaction which proceeds with moderate speed, and we call it as moderate reaction. Okay, not very fast, not very slow. Okay, so based on the speed of a reaction, the reaction are classified into these three categories. Okay, very fast reaction, instantaneous, very slow reaction, and moderate reaction. Okay, moderate reaction, we also call it as molecular reactions. Okay, very fast reaction, we call it an instantaneous reaction, and the other name of this is ionic reaction also. So as the name suggests, these reactions, very fast reactions, are those reactions which occurs with a very high speed or high rate. Means you cannot even imagine, and the reaction gets over. Okay, usually it will take time to finish, around 10 to the power 14 to 10 to the power minus 16 seconds. You don't have to memorize this, but just for your understanding, I'm telling you this. Like the time required to finish this kind of reaction is around 10 to the power minus 14 to 10 to the power minus 16 seconds. You see, you cannot even imagine this time, and the reaction gets over. That's why the reaction are very fast reaction and instantaneous reaction. Like example, we can have neutralization reaction, acid-base reaction, which are very fast reaction. Okay, NaOH plus HCl gives NaCl plus water. Or the reaction in which precipitate forms, PPT forms. PPT stands for precipitate. Okay, like for example, AgNO3 combines with NaCl and forms the precipitate of this NaNO3. Is it visible here?
Yes, sir.
Okay. This is first type of reaction. Why these reactions are very fast? Actually, you can understand this because it involves the exchange of ions. You see, these are salt present in Na plus and Cl minus, Ag plus and NO3 minus. So here we have exchange of ions into this. Ag plus takes the Cl minus, forms AgCl. Na plus takes NO3 minus, forms NaNO3. So ions are getting exchanged, hence the reactions are very fast in this, right? Very fast reaction. Very slow reaction, which takes months or year to finish. For example, we can have rusting of iron, very slow reaction. Or formation of water at room temperature. H2 plus O2 gives 2H2O. This reaction at room temperature. That is also very slow. Okay. Even the reaction of carbon plus O2 at room temperature, CO2, that is also very slow. Evaporation process. Evaporation. However, evaporation is not a reaction, but it is also very slow. You should not write this one, just let it be. Evaporation is not a reaction. Okay. But in this, why I'm writing it down, because H2O liquid is converting into H2O gas. Okay. The process is there. That process is also very slow process. Okay. Moderate reactions are what? These are the reaction which proceeds with a moderate rate, not very fast and not very slow, right? So like, for example, we have growth of bacteria. Growth of bacteria, okay? And suppose we have dissociation of H2O2. O2, okay? Even if you have formation of ammonia from N2 plus 3H2. So all these are moderate reactions, okay? Now, why we are discussing all these three things here? Because, when the reaction is very fast, you see this? When the reaction is very fast, this is the time required to finish this reaction. So for this reaction, it's very difficult to find out the rate. Okay, for this reaction, it takes place with a very high speed, and it's very difficult to find out the rate of the reaction. Okay, very slow. What happens? It takes months or years to finish. Okay, 2, 3, 4, 5 months like that takes. So in this reaction also, there's no practical importance of this to find out the rate of this kind of reaction because it's very slow. Okay, so here we do not have practical importance, and for very fast reaction, it's very difficult to find out the rate of the reaction. That's why in this chapter, mainly we are going to deal with moderate reaction. Okay, so hence moderate reactions are important reaction for this chapter. Mostly we are going to deal with those reactions which proceeds with a moderate speed, that is not very fast and not very slow. Is it clear? Any doubt till here? Yes, guys, please respond.
No, sir.
No? Correct. Now, to proceed with this reaction, like I said, that we have to deal with the rate of the reaction mainly. Okay, so first of all, we define what is the rate of a reaction. Have you done this chapter before?
No, sir.
Okay. Like I said, the rate of a reaction is, and rate means what? Per unit time calculation is rate. Okay. So we calculate this with respect to time. Whatever, like for example, I've given you the examples of the speed, velocity, acceleration. Okay, that is it. So here also we have change in anything per unit time is the rate, right? So in a chemical reaction, what happens? We mainly deals with the concentration of the reacting species or the pressure. Okay, concentration of the reacting species or the pressure. Hence, the rate of a chemical reaction is defined as rate is equals to the change in concentration of reactant or product. Okay, and this is divided by the time required to produce that change. Okay, that is the rate of the reaction. Concentration by time. This we also write it as delta C, change in concentration, by delta T, time required to produce that change. Okay. Suppose if the reactant or products are given in gaseous form, then what we'll write? The change in what? If gaseous form is given, then change in pressure of reactant or product divided by again the time required to produce that change. That should be equals to delta P by T. Delta P by delta T. Clear? So this basically, this formula we use, the second formula we use for gaseous phase reaction. You don't have to memorize this. You will understand once you see the question. Okay. This one we use when the reaction is in aqueous phase. So aqueous phase will talk about concentration. Gaseous phase will talk about pressure. Okay. Now I would like to make you understand this particular thing with an example. Okay. So how do we write down the rate expression? That is very important, and it's very important for exam point of view also to understand the rate. Okay, how to write down the rate of a reaction. Now suppose I'm assuming a reaction, say, okay, I am assuming a reaction, say A gives B. Okay, A gives B. Now what I'm assuming, at time t is equals to 0, the concentration of A is small a, and this is 0. There's no B, only A was present, and this A converts into B. So after some time T, suppose A starts converting into B, so concentration of A decreases. So suppose this is the amount that reacts and it forms X. No doubt? Any doubt in this?
No, sir.
No, sir.
Suppose if I write down this reaction, then what we'll have here? A gives 2B, then what we get here? A gives 2B. Suppose we have A minus X. What is the amount of B we'll get here? Yeah. Tell me, what is the amount of B we'll get here?
X by 2.
X by 2, right? How do we get X by 2? Because 1 mole of A gives 2 mole. So X mole of A gives 2X, not X by 2, right? So 1 mole gives 2. So X mole gives 2X here, right? So we'll get here 2X. Did you understand? So molar ratio will follow. I have taken here 1 mole of each. That's why 1 mole gives 1. So X mole gives X. Okay. Now the rate of the reactant here. You see one thing, rate of reactant is different from the rate of the reaction. Okay. Rate of the reaction is different, and rate of any species, whether it is reactant or product, is different. So here I have written just rate, right? And here I'm talking about the rate of this reaction. Before that, we'll discuss the rate of individual species. So rate of A will write. What is A? A is the reactant. So rate of A, rate of reactant are same thing, right? Reactant is getting consumed. So rate of consumption also we write it as. All these terms they use in the book. So you must know the terms that we are using. Rate of A is the reactant. Reactant is getting consumed, so consumption, or we can also say rate of disappearance. So all these terms we use for the reactant species. Okay, is equals to, what should we write? Change in the concentration of A divided by the time required to produce that change. Okay, so we will write delta concentration of A by delta T. Okay, whatever is written in square bracket, that is the concentration. So concentration of A by T. Now when you solve this at time T, it is A minus X. So it is A minus X minus the concentration at 0, it is A divided by the time is T minus 0. Did you get it? This expression?
Yes, sir.
Right? So finally we get this as what? Minus of X by T. Right? Okay. So this is the expression we get. Now one thing here, since we are writing down the rate of reactant and that we are getting negative. So negative rate does not have any significance. To make this positive, we'll write down the negative sign here. We multiply the negative sign here, so this becomes positive. Okay. So what you need to understand, the rate of any reactant species will write, we always write negative of change in the concentration divided by time required to produce that change. Okay, no doubt in this. So rate of any reactant we always write with negative sign. We don't write plus or delta C by delta T or delta A by delta T. Rate of any reactant is always minus delta concentration of A by delta T. Correct? Now, the next thing, the rate of the product, right? The rate of the product, that is B. So what we can write? The rate of B, or B is the product, or the product is uh, rate of product, rate of production also we can write, and the product is getting formed. So rate of appearance, all these things are same. That would be equals to, again, change in concentration of B by time required to produce that change. Okay. Now, if you look at the reaction, again, since reactant I have written minus sign here, so product I will write, okay, we'll discuss that later. Okay. So the concentration of B at time t is x, minus at time t is equals to 0, it is 0, divided by t minus 0. So it is x by t. Okay. Now, since reactant I have written with minus sign, so for product we'll write plus sign, plus, plus, and plus. Clear? Now, to summarize this, whatever we have discussed now, what we can write? Rate of reactant is equals to minus of change in concentration of reactant. I'll write down here. Minus of change in concentration of reactant by time required to produce that change. Rate of product is equals to plus of the change in concentration of product by time required to produce that change. Okay. This is basically, when I say rate of reactant, it means the rate at which the reactant is getting consumed. That is what it means. Rate of product means the rate at which the product is forming. Correct? Now you see this graph and will understand one thing here. And I'm sure you must have done this in physics also in 11th grade. Usually the reaction has the change in concentration. This is the concentration of reactant, y-axis, and this is the time axis we have. Okay, so the graph usually goes like this. It goes like this. Means when the reaction proceeds, you can understand this graph easily, and you can also ask me, so why the graph is going like this? Okay, why not it is going this way, straight line going down? That also you can ask. Okay, we'll discuss that later. The graph depends upon the order of the reaction, so we'll discuss that later. Let us just assume that the graph is like this. Okay, reactant graph, obviously it is going this way because when the reaction proceeds, the concentration of reactant will have some value, initial value, and then it starts decreasing because the reactant is converting into product. Right, so all of you has no doubt in this particular graph. It is going down because the concentration is of reactant is decreasing. Okay, so if you cannot unmute and talk, you can write down the, like, you can text me, you can use the chat box for the response. Okay, no doubt you can type CLR in the chat box. Okay, thank you. So you see here what happens at time t is equals to 0. You see, at time t is equals to 0, the concentration is this for the reactant. And suppose at time t, when the reaction proceeds, the concentration becomes this. This is suppose time t we have. And this is Ct at time t. This is C naught is the initial concentration. So if I ask you with this graph, if I ask you the rate of reactant, what is your answer? Tell me. See, first of all, when I say rate of reactant, you should simply think about this. Minus of change in concentration of reactant by time. First of all, you should write this. Then only you start thinking. Then what we have? Change in reactant concentration. So what is change in reaction concentration? The time we have, it is T minus 0. And at time T, the concentration is Ct. At time 0, the concentration is C naught, negative of it. So it is minus of Ct minus C naught divided by T. Okay? No, it's not area. It's not area, Vinay. Right? It's just this difference by the time. This difference by the time. That is what we have here. Okay, so now you see what I'm trying to make you understand. We calculate this rate over a period of time. Means in this range, what is the change in concentration we have? That is the rate we are calculating. Okay, so this rate we call it as, since it is over a period of time, so this rate we call it as average rate. Average rate. Okay, right? So two types of rate also we have, average and instantaneous. Okay, now you see this, if this delta t becomes 0, can I go to the next page? All of you have written this? Okay. Now I'll draw this graph again. Quickly, let me just draw this graph. Go this way, right? So if I find out this, you see the rate of the reaction, rate of reactant is equals to minus of delta, just a second, it is delta R by delta T minus of this, correct? So now what I'm thinking here, if I write down this minus delta R by delta T, where the limit, if I use limit delta T tends to 0. Okay, now you see this graph here, when delta T tends to 0, then what happens? This point, this difference you are trying to make it as 0, means you are shifting this point left side towards this 0. Yes or no? What do you understand by delta T tends to 0? This means what? You are shifting this point here close to this 0. Yes or no? And when it is possible, when this point and this point are just next to each other, means just very close to each other. Yes or no? Please type Y or N in the chat box quickly. When this point, when delta T tends to 0, means this point is very close to this point, then only delta T will be 0, correct? So what is that condition we'll see here, right? So when delta t tends to 0, this point I'm writing it down, it means the 2 point will be very close to each other. Any 2 point we can take. This point, suppose I'm taking the point over here. For any concentration value, I'm taking the point over here. These 2 points are very close. Now, if you draw a line to join these 2 points here, the line will be what? The line will be suppose this is a line we have. I'm just removing this one. This point I'm removing. Okay, suppose the graph is like this. And suppose I'm considering this point here. These 2 points I'm considering where the line has been joined. Okay. So now when you join this line, then this thing becomes what? The slope of this line is nothing but dy by dx, correct? Which is concentration axis here and time axis here. So this expression, if you remember, this is nothing but the the definition of derivative dc by dt. This is the definition of this. See, we have r here, so we'll write down r, not c. This is the mathematical definition of this. Simply, if I write down here, minus of limit, suppose we have delta x tends to 0, delta y by delta x. So this becomes dy by dx. This is the mathematical definition of derivative, minus of dy by dx. Okay, the same thing we have here written here. Now coming back to the point which is useful for us, why I have drawn this graph, because this is the slope, this is a straight line, and the slope of this line is nothing but the dr by dt or dc by dt here, right? So that's why I have drawn this line. But the point is, when you write this expression, it means we are talking about a point, because delta t tends to 0. You see, it is a single point we can take it this as. So at this point, the rate we have, that rate we call it as instantaneous rate. So this one is instantaneous rate. Okay. And when you write simply delta r by delta t over a period of time, when you're talking about, that is the average rate. Okay. Now the point that you have to understand, if you understood this, fine. Otherwise, you just keep this in mind. That is more than enough to make you understand. Okay. This we can also write it as rate of the reactant minus of deconcentration of r by dt. This also we can write plus of deconcentration of the product by dt. That also we can write. But the only difference is, however, this does not make any difference into your answer. But the only difference is this expression is instantaneous, and this one is also instantaneous, but these are what? These are average. That is the only difference we have. Okay. Mostly for derivation and formula, we'll use this expression, instantaneous. We'll use this one. Is it clear? Instantaneous and average rate. Instantaneous is defined for one specific point. Average is defined for over a period of time. 0 to t is average, and at a single point, it is instantaneous. So we have discussed about the types of the rate of the reaction. That is, we have two different types of rate of the reaction, average and instantaneous rate. Again, I am telling you, this difference is not that important. Okay, instantaneous and average, you should know this. Okay, what is the difference of dr by dt and delta r by delta t? Average and instantaneous. Okay. Now, one more thing I would like to gain your attention here, that we are talking about the rate of reactant product, we are not talking about the rate of reaction. Again, I'm telling you both are different. Okay, rate of reactant and product is different from the rate of reaction. Okay, so when you look at this expression, okay, suppose if I write down this one, you see here, I'll just take one more example to make you understand this. Here, the first one I have taken simply A gives B. Okay, now for this example, could you tell me what is the rate of reactant? For this example, you see, suppose the next example I am taking here, 2A gives 3B. Okay, at time t is equals to 0, the concentration of A I am assuming, initial concentration, A I am assuming, suppose A naught, this is 0, and at time t is equals to t, this becomes A naught minus 2x, and this becomes 3x. No doubt in this? No doubt in this?
No, sir.
Correct. Now, what is A? What is the rate of reactant A? Rate of reactant. Rate of reactant, if I ask you, you don't have to think anything here. Just what you have to write down, minus of delta A by delta T. This is the rate of reaction. Is the average one. Instantaneous is what? Minus of D concentration of A by dt. What is the rate of product? Minus of, oh sorry, not minus, plus of dB, delta V by delta T is equals to plus of D concentration of B by dt. Now, did you find any difference here in the rate of reactant and product expression of this reaction and the previous one, this reaction? Did you find any difference in both? You see this? This one, you compare this expression and this expression. Do you have any difference? No, right? There's no difference, correct? Do you have difference in the reaction? Do we have difference in the reaction? The first one is A gives B. Here it is 2A gives 3B. So we have difference in the reaction. So the two different reaction we have, but the rate of reactant and product, the general expression is same. Means the rate of any individual species, whether we talk about rate of reactant and rate of product, it has nothing to do with the stoichiometric coefficient of the reaction. Okay, so whatever reaction is given, right, whatever reaction is given, right, we always write down the rate of reactant and product with this expression irrespective of the stoichiometric coefficient of the reaction, right? Okay, why area under the this curve, why we are not considering Vinay? Because we are considering 2 points. Okay, so any 2 points you have to define. To define the rate, you have to take two different concentration at two different time, right? Hence, we are taking two different concentration. So the whole graph we cannot take. We can take this and this, the change between that. Are you getting it? Correct. Okay. So what we can say here, the reactant, just a second. So for this, here you see, I'll write down one expression here. This we can write it as, you see, minus of d by dt of change in concentration of A, which is A naught minus 2x minus a naught. I'll write down other side. Wait, I do not have space here. So I'll write down other side the same expression. Or I'll write down this side, probably you'll understand this. Rate of reactant A minus dA by dt. So we can write minus of d by dt of a naught minus 2x, this one, minus the initial one, which is a naught. So which is coming out to be what? Which is coming out to be here as 2 into minus dx by dt. Is this fine? You write down like this only, the way I have written. Similarly, this one is what? If you solve this, you will get plus of d by dt of 3x minus 0, which is equals to 3 plus dx by dt. Any doubt in this? No?
No, sir.
Okay. Now you see this expression. What is minus dx by dt? Minus dx by dt is equals to half of minus dA by dt. Right? Is it fine? Minus and minus will get plus here, no? Minus minus becomes plus. Okay. So dx by dt is what? Half of minus dA by dt. And from this dx by dt is what? 1 by 3 of dB by dt. Just you compare this expression and this. So what we can write here, you see, we can write minus of d concentration of A by dt is equals to 3 plus dx by dt, and we can also write plus concentration of dB by dt is equals to what was the expression? Okay, here we have 2, here we have 3. Okay, I'll just make a change here. This one is 2 and this is 3 plus of dx by dt, correct? Now, if I equate this from this expression, what we get, we are just almost we are done with this. You'll get the final expression here. Dx by dt is equals to half of minus of d concentration of A by t. And this expression becomes, you write down this way only, plus of dx by dt here is equals to 1 by 3 of plus of d concentration of B by dt. Again, you write down this way only. Okay. Now, when you equate the two term dx by dt, sorry, this is dt here. Now, when we equate the two term dx by dt, the entire expression we get is dx by dt is equals to half of minus d concentration of A by dt is equals to 1 by 3 of plus d concentration of B by dt. Okay, this is the expression we get. Okay. Now you see the very important point here. Now you see This dx by dt, this expression I'm talking about, this dx by dt is the rate of reaction. This negative thing in the bracket is rate of A, the reactant. This expression in the bracket is rate of B, the product. Yes, it is a stoichiometric coefficient here. This is the stoichiometric coefficient 2 and 3. Now, is it clear? dx by dt is the rate of reaction. Minus of dA by dt is rate of A. Plus of dB by dt is rate of B. Rate of A is what? A is the reactant. B is the product. So reactant rate will write with negative sign. Product with positive. Did you understand this?
Yes, sir.
Correct? Now the most important point here, why I have taken so much time to explain you this, you will understand it now. Okay, I can give you this expression in just 2 minutes, that for any reaction you can write down the the expression this way. Okay, now what we observe here, that the rate of the reaction, you see, it depends upon this stoichiometric coefficient. Yes or no? So rate of the reaction depends upon a stoichiometric coefficient. But the rate of the individual species A and B, this thing, these are independent of how many of you understood this? Independent of stoichiometric coefficient. Did you understand this? Okay. Now you see, if the rate of reaction depends upon the stoichiometric coefficient, okay. So if the reaction is not given, listen to me very carefully, okay. If the reaction is not given, then we cannot find out the rate of the reaction. Okay. We can find out the rate of individual species, means we can find out the rate of reactant and product, but rate of reaction we cannot find out if the reaction is not given. Okay, write down this point. Write down, since the rate of reaction depends upon the stoichiometric coefficient, depends upon the stoichiometric coefficient of a balanced chemical equation, hence it cannot be calculated, hence it cannot be calculated if the reaction is not given in the question, or if the reaction is not mentioned, or if the reaction is not given in the question. If it is not given, it cannot be calculated. Okay. Next line. Next line. The rate of, write down, the rate of individual species. Individual species means any reactant or product. Okay. The rate of individual species is independent of stoichiometric coefficient. Hence, it can be calculated. Even if the reaction is not given. Correct? Done?
Yes, sir.
Okay. Now, one general expression we'll see. Yes, Pranav, any doubt you have? Pranav, any doubt? No? Yes? You raised your hand. Okay, let it be. Okay, now you see this example, one general example, I'm just talking about it. Suppose we have a reaction AA plus BB gives CC and DD. What I am assuming, this is a balanced chemical reaction. Okay, it is given. It is a balanced chemical reaction. Okay. So the rate of reaction is what? Sorry, the rate of A. What we can write? Rate of A is what? Tell me. What is the rate of A?
Minus the concentration of
Minus concentration of
A divided by delta T.
delta T. Okay. Rate of B. Again minus dV by dt. Rate of C. C is the product, so we'll write plus dC by dt. Rate of D plus D concentration of D by dt. Why am I writing it down? Because it has nothing to do with the stoichiometric coefficient. Just rate of reactant minus of concentration of reactant by time. Whatever the stoichiometric coefficient is there. Okay, the expression is always this because it is independent of stoichiometric coefficient. Okay, what is the rate of reaction? ROR is equals to, if I write down in terms of A, it is 1 by A minus of dA by dt. Yes or no? Quickly. right? That is what the expression I have written here, you see, in the previous example. dx by dt is rate of reaction. Rate of reaction equals to 1 by 2 minus of dA by dt. 1 by 3 minus plus of dB by dt, where this 2 and 3 are what? You see this reaction we have, 2A gives 3B. 2 is the stoichiometric coefficient of A, 3 is that of B. Is it fine? That should be equals to, in terms of B, what we can write? This we can write in terms of B. In terms of C, what we can write? In terms of D, what we can write? Anyone has doubt in this? Clear, all of you? Understood this?
Yes,
Yes.
sir.
Yeah. Now you solve this question based on this. Suppose the reaction is 2A plus 3B gives 5C. Now, at time t is equals to 0, it is given 10 molar. And at time t is equals to 20, it is 5 molar. Okay, second it is. What we need to find out, find RA, the rate of A, the rate of B, the rate of C, and ROR. A, B, and C, and rate of reaction. Try this. Done. What happened? You're not getting it? Okay. Okay. You see, what is RA? Rate of A. And could you tell me what is the rate of A?
1/4.
1/4.
So what is the formula we have? Rate of A is equals to
Minus
minus dA by dt. Okay, which is equals to minus dA means change in concentration of A. Means it was initially 10, finally becomes 5. So what we can write? 5 minus 10 divided by the time required to produce that change, which is 20 minus 0. So minus of 4 by 20 is equals to 1 by 5 molar per second. Correct? Oh, it's minus minus plus. Got it? Plus, you won't get minus, you'll get plus. Okay? Rate, you never get minus. Minus rate does not mean anything. Okay? And to minimize this only, to reduce this thing only, that you should not get the minus sign, here in the final answer, we have taken this negative sign. Okay? Plus 1 by 5. Now, what is the rate of B? Can we find out rate of B?
3/8.
3 by 8. Acha. One more thing you tell me. If I ask you rate of A, we know, right? Now, can I write down the expression of ROR here? Rate of reaction. What is the rate of reaction we can write?
The rate of A should be minus plus 1/4.
Rate of C.
Rate of A should be 10 minus 5 is 5, not 4.
Oh, I have written it wrong. Anyway, it's 5. So this is 5 divided by 20, 1 by 4, right?
Yes, sir.
Molar per second. Correct? Okay. Now we know we find out with the given data, right? So you see what happens. Rate of A I have written minus of dA by dt irrespective of the stoichiometric coefficient. So to find out the rate of any individual species, what we need concentration at 2 different times. That is it. We can subtract divided by the time required to produce that change. That is the rate of that particular species, correct? But for A, it is fine. We calculated by this. B and C, it's not given. Means the concentration for B and C at 2 different times is not given. Now to find out RB and RC, we'll use this expression of ROR. That we can write ROR is equals to 1 by 2 of minus of dA by dt. So rate of reaction, if you write down, then we'll use the stoichiometric coefficient. 1 by 3 of minus dV by dt. And it goes to 1 by 5 of plus dC by dt. Okay, so we know this value. We know minus of dA by dt. Minus of dA by dt is 1 by 4. So could you tell me what is minus of dB by dt? Rate of B? Is equals to 1 by 4 into 3. So 1 by 2 into 1 by 4 into 1 by 3, that is 3 by 8 molar per second. Is it right? Or if you relate this, plus of dC by dt is what?
5/4.
5 by 4 or 5 by 8. Half also we have here, this 2. Correct?
Yes, sir.
What is ROR?
1 by 8.
1 by 8. You see, whatever you take, with this also you'll get ROR 1 by 8, ROR 1 by 8, ROR 1 by 8. So rate of the reaction is 1 by 8 molar per second. Okay. Rate of individual species also we have seen. Okay, got it? Now one last thing we'll discuss here, which is the unit. Unit of rate is what? For aqueous phase, we know
Molar per second.
rate is equals to change in concentration by time. So that will be equals to concentration is what? Mole per liter. Divided by time. Okay. This time, the unit of time could be anything. It can be second, it can be hour, it can be minute, it can be day, week, year, anything. Anything is possible. Okay. Depending upon that, we can write down the units. So mole per liter, time is the unit of rate in aqueous phase. In gaseous phase, we need pressure, right? So rate is equals to change in pressure divided by time. That would be equals to atmospheric divided by time. Again, the time unit can be anything. No doubt. Done. Now you see this question. For the formation of NH3, from nitrogen and hydrogen N2 and H2. The rate of N2, R of N2 is given. It is 1.5 into 10 to the power minus 3 molar per second. You need to find out rate of reaction, ROR. Options are given. Into 10 to the power minus 3 molar per second. Second one is 3 into 10 to the power minus 3 molar per second. C is 10 to the power minus 3 molar per second. Option D is cannot determine. Try this question, all of you.
Option A.
Is it A? All of you are getting A? Tell me.
Yes, sir.
Okay, so all of you are getting option A. Fine. What is the reaction we have here? This reaction we can write, and hence the ROR is what? Minus of N2 by dt is equals to 1 by 3 of minus of dH2 by dt. Okay, and so on we can write for NH3 also. So this Rn2 is given. So ROR is what? 10 to the power minus 3 molar per second. And that is what you are getting. Yes. Option A. Okay. Now you see one more thing here. Can I write down this reaction? Is it fine? Then the ROR of the reaction is what? That will be twice of the rate of N2, which is 1.5 into 10 to the power minus 3. So that is coming out to be 3 into 10 to the power minus 3 molar per second, which is this. Yes, Kirtana, tell me. Which negative sign? No, actually see here what happens. See, this negative sign should not be. I'll tell you why. By mistake I have written this. Because rate of N2 is nothing but minus of dN2 by dt. So minus of dN2 by dt is 1.5 into 10 to the power minus 3. Hence, the answer will be positive. Clear? Ashwarya, understood this?
Yes, sir.
Correct. Yes. Why Kirtana? Why 1 mole is formed? Why it is required? Is this reaction not correct?
Sir, in second reaction, you have divided everything by 2. So 2 by
Yes.
2, 1 mole of ammonia.
All right. So we can, for this reaction, we can write down this expression, no?
Yes, sir.
Correct. So answer I am getting different. What is wrong in this?
Nothing.
So we must divide rate of n2 by 2 also.
Rate of n2 by 2. And that's what I have done here. 1 by this into d of n2 by dt.
So we must divide minus d n2 by dt by 2 also.
By 2, again we have divide.
Yes, sir. So 1.5 10 to the power of minus 3 should be divided by 2. If you are multiplying the whole equation by 2.
No. That why are you are saying that to get this answer? No. Right. What is wrong in this expression? I just want you to understand this. What is the formula of ROR we were getting? ROR is equals to 1 by A of dA by dt, correct?
Yes, sir.
What is A here? Half. 1 by A minus of d into b. What is wrong in this? Hmm? Nothing. Chalo, I'll write down one more reaction here. What is the reaction here? I'll show you. Suppose I'll write this reaction. Can I write down this? Is this fine? What is ROR then? Is this fine? Tell me.
0.75 into 10 power minus 3.
You see, I'm getting C option also. All the options are correct. Now, is this wrong? The third one? What happened?
Sir, for 1 mole of nitrogen, the rate of reaction is 1.5 to 10 to the power of minus 3. But half mole of nitrogen is half of that.
Is it given in the question that 1 mole of nitrogen is this? Is it mentioned? Why you are taking, suppose this question you got, okay, you have taken this, okay, someone has taken this reaction, I have taken this reaction, right? Because it is not mentioned in the question how many moles of NH3 we should get. It just said N2NH2 reaction forms NH3. So you have taken this reaction, I have taken this, and someone has taken this. So we three are getting three different answers which are there in the options, and all three cannot be correct because the condition of reaction is same. So when the reaction proceeds, it must have one single rate of the reaction. Are you getting it?
Sir, we have to take the lowest possible whole number as the stoichiometric coefficient.
No, why lowest possible number of moles you have to take? See why you are saying this, because we usually write N2 plus 3S2 gives 2NH3, right? But it is not like that this reaction you cannot take. This reaction you cannot. You can take any reaction. Even if you multiply by 4 into N2, you'll get some other reactions, the rate will be different. Okay? Now the answer for this question is, see, you can take any of these three reactions, even if you can take infinite number of reactions like this. And that is why the answer for the question is this one, cannot be determined. This is also wrong, this is also wrong, this is also wrong. Now I'll tell you what is the logic behind this, why this cannot be determined. I have told you one thing, that ROR depends upon what? Depends upon what?
Stoichiometric coefficient.
Stoichiometric coefficient. Okay, now you see this is the very important examples and very good examples you have which you can understand this. Now when you write down this reaction and this reaction, you are changing the stoichiometric coefficient, yes or no, quickly.
Yes, sir.
Since you are changing the stoichiometric coefficient, you are getting different rate of the reaction. Correct? So point is, in the question, the catch of this question is, in the question, they haven't mentioned the reaction. Have they given the reaction in the question? No. Reaction is given in the question? No. What you have done, you have assumed the reaction, which is this. You cannot assume the reaction. What I've told you, that it depends upon the stoichiometric coefficient, and we cannot find out the rate of reaction if what? If the reaction is not given. I've given you this particular point, right? Yes,
sir.
correct. So in this question, what mistake you have done, that you have assumed the reaction, this or this or this. Hence you are getting 3 different answers in the question. Since the reaction itself is not mentioned in the question, we cannot find out the rate of the reaction. It is the other thing that we know the reaction. We know the reaction that N2 plus 3H2 gives 2NH3. We know this reaction, right? But since it is not given, we cannot find out. Answer would be D, cannot determine. Correct? This question was asked in JEE exam, JEE mains. Okay? And most of the students, more than 95%, more than 90% of the students, they have done this, which was the option. And they feel like, okay, I have done everything correct. Okay, but they eventually they got -1 into this. Okay, so that is how you see the concept is very small, right? I told you that time only, you listen to me carefully. Okay, the concept is nothing, right? But one small thing you didn't take care of and you got the -1, right? So the point is what? If the reaction itself is not given in the question, we cannot find out the rate of the reaction. It is the other matter that we know the reaction. And you know, the thing is, the point, you see how they frame the question. This actually helps you whatever exam you will write. Okay, you know how they frame the question. They have taken this example because most of us knows this reaction, no? Correct? I think every one of us knows this reaction. N2 plus 3H2 gives 2NH3, Haber's process. Yes? Correct? So they have taken very simple reaction, very simple example they have taken so that you would make this mistake or this mistake or this mistake. Okay? So all these competitive exam, whether you write BITSAT, VIT, Comet K, KCET, any other exam, okay, they don't choose, they don't select students, but they reject students. Okay, rejection is easier. See how many people are going to write the exam? Tell me. More than 15 lakhs, right? Every year. More than 50 lakhs they write the exam. And out of this 15 lakhs, they are going to select 10, 15, 20,000, 30,000 candidate. Okay. I'm talking about JEE mains. More than that, 50,000 max to max in JEE mains, right? Comet K BITSAT is, number is this only, but less than this. Like very less than this number that is selected. So if I ask you, suppose one simple example I give you, there are 20 people, right? And if I ask you to select 1 people with the interview, you have to take the interview of 20 guys and select the 1. This is one thing. If I ask you to reject 90 people, which one is easier? Rejection or selection of 1 people out of 20? Right? Rejection is always easier, right? So all these exams, what they do, they actually do not select students, but they reject students because that is easier. Okay, so this kind of questions they only ask in the exam. It is not like only for J. However, this question has been asked in J exam, but this you would get in any other exam. It is not very tough questions or something like that. Only you need to know the basic concepts of rate of reaction. Okay, understood all of you this? Okay, so don't think all this. 1 mole is required, so we'll write down this reaction, won't write that reaction. Okay, don't think. Here we should have 1 mole. I think you're talking about this that time, right? Is it? You're talking about this 1 mole of NH3? Anyways, so this 2 I have written it by mistake. It should be 1 mole here, 4 mole here, and 2 mole here. Anyways, correct. Got it. Yes. Got it. Right. No issue. So the thing is, we cannot assume the reaction, and hence we cannot find out the rate of reaction in this question. The answer would be the what? Cannot be determined. One more very good questions we'll see. Try this one. The reaction is given here. Always keep this in mind. If the reaction is not given, you cannot find out the rate of the reaction. Okay, N2 plus 3H2 gives 2NH3. Okay, rate of ammonia is given, R of NH3. Rate of ammonia is given. It is 1.7 kilogram per hour. For this given reaction, you need to find out the rate of hydrogen, H2, in gram per minute. (42.5 gram per minute). Okay. What we can write here, R of N2 is equals to 1 by 3 R of H2 is equals to 1 by 2 R of NH3. See, R, when you write R of NH3, it means plus DNH3 by dt. R of N2 means minus of dN2 by dt. That's why I haven't taken any sign over there. Okay. H2 means, R of H2 means minus of dH2 by dt. Correct? Now, what is R of H2 here? 3 by 2 into R of NH3. R of NH3 is 1.7. It is given in kilogram per hour. So to convert this into gram, we have to multiply 1000 here divided by minute, right? So for that, we have to multiply 60 in the denominator. So when you solve this, you'll get 170 by 4, and that would be equals to 42.5 gram per minute. Is it clear?
Yes, sir.
This is what you did. All of you, tell me.
Yes, sir.
Yes, sir.
But this is wrong. You know the reason why? Achha, tell me one thing. What is this 3 and 2? This 3 and this 2?
Stoichiometric coefficients.
So what we can say here, can we say 1 gram of N2 reacts with 3 gram of H2 gives 2 gram of NH3? Can we say that?
Yes, sir.
No, we cannot say that. This stoichiometric coefficient is not the mass ratio, but is mole ratio, correct? We can say 1 mole of N2 reacts with 3 mole of H2 and gives 2 mole of NH3. But this is given in kilogram, 1.7 kg. So we are comparing kg with moles because 3 and 2 are the moles. And this is kg. So this we cannot compare like this. To compare this rate and the number of moles here, we have to convert this into mole first. Okay. So what we can write, this expression R of H2 is equals to 3 by 2 of R of NH3. R of NH3 actually, you have to first convert into mole per, since minute you have to find out here. So R of NH3 will convert into mole per minute, and then we can compare this. So R of NH3 is 1.7 kilogram per hour, right? So kilogram, we convert this into gram first. So 1000 divided by 60 if you write, then it becomes what? Gram per minute. And the whole thing, if it divides the molecular mass of NH3, what is that? Molecular mass of 17. So this gram divided by molecular mass becomes what? Number of moles?
Moles.
100 by 60 mole per minute. Yes or no? Did you get it?
Yes, sir.
Mole per minute. Now this we can compare here. So we can write R of H2 is equals to 3 by 2 into 100 by 60 mole per minute. So this will get what? 20, 100 by 40. So it is 5 by 2, correct? 5 by 2 mole per minute, right? Of R of H2. When you solve this, 5 by 2 only, no? It is 40, 40, 20 into 2, 40, 100 by 40 is 10 by 4, 10 by 4 is 5 by 2, correct? 5 by 2 mole per minute we are getting. But answer is what? We need to find out in gram per minute. So R of H2 in gram per minute, we need to convert this mole into gram. So 5 by 2 mole into what we can write? Molecular mass of H2, that is 2. This expression is what? Gram per minute. So this is 5 gram per minute. The answer is this. How many of you understood this? Now you see how they frame that question. Okay, they know where you can make mistake, and that thing only they'll ask. Okay, so always keep that in mind. The stoichiometric coefficient represents the number of moles. It is not mass ratio, right? It is mole ratio. So we can always compare with mole only. We cannot compare mass and mole. So whenever the rate is given in mass, right, then you have to change that mass into mole, and then we can do the calculation like this. Understood this? Clear? Okay. We have discussed about the rate of the reaction. Okay. Concepts also we have discussed, few questions also we have seen. This is very important, the rate concept and all. That's why I have taken so much time to make you understand this. Okay, now we can go a bit faster to finish the portion. Okay, so there are few terms we use before, in this chapter. That term definition you must know. The first term that we use here is reaction lifetime. Write down reaction lifetime. Write down the definition to this. It is a time required It is a time required It is a time required to complete 98% of the reaction. 98% of the reaction. You can ask me why not 100%, correct? Actually, you see what happens as the reaction proceeds. Okay, as the reaction proceeds, the concentration of the reactant species decreases, correct? And hence the rate also decreases. And rate keeps on decreasing and decreasing and decreasing. And eventually the reaction becomes extremely slow, right? So even when 98% of the reaction reaches, the reaction tends to stop over there because the concentration is very low and the rate becomes extremely slow. So we do not wait for 100% of the completion, or practically it takes a lot of time to complete 100% of the reaction. Hence we assume that 98% is the only, the extent we have of the reaction. And we assume at 98% the reaction is finished. So that the assumption will take since the reaction rate becomes extremely slow, right? Hence reaction lifetime is what? It is the time required to complete 98% of the reaction, correct? This is one thing. Another thing you write down, reaction lifetime. So half lifetime. Reaction lifetime we have done, half lifetime. What is half lifetime? Oh, one more thing I forgot to tell you here. The reaction lifetime here, it is inversely proportional to the rate of the reaction. Is it right? The reaction lifetime, more rate, lesser will be the time required for the completion of reaction. So it is inversely proportional to the rate of the reaction. Faster rate, lesser will be the lifetime of the reaction. The next one is half lifetime. Half lifetime. Half lifetime is the time required, write down, is the time taken or required for 50% completion of the reaction. Okay, it is represented by T half. This one is important. 50% of the completion of reaction. T half, or we also write it as T50 like this. Okay, T half or T50. So it is time required for 50% of the completion of reaction. Now, next thing we'll see the rate law and rate constant. And rate constant. Okay. So rate law is what? We have discussed how to write down the rate expression. But rate law is what? Suppose I have written a reaction, AA gives plus BB gives product. Okay, A plus BB gives product. Okay, so the rate, according to rate law, the rate of this expression, this reaction we can write, rate is directly proportional to the concentration of A into the concentration of B to the power any number. Okay, this number is experimentally determined, X or Y. Okay, X or Y, this number is experimentally determined. There are reactions in which, means we can have this X is equals to A and Y is equals to B, respective stoichiometric coefficient. This is possible, but we can have this as well for some reactions. Okay, so this power here, the exponent of this concentration term in the rate law expression we have, this can be any number. It can be equal to the respective stoichiometric coefficient or may not be equal to the respective stoichiometric coefficient. Okay, so this expression we call it as the rate law expression, and this is defined at a given temperature. Okay, now when you remove this proportionality sign, you will get rate is equals to a constant K into concentration of A to the power X, concentration of B to the power Y. Okay, where you write down this K is the rate constant, we also call it as velocity constant, or we also call it as specific rate of reaction. All these terms we use for K. Okay, specific rate of the reaction. Correct? X and Y are the experimentally determined quantity. Okay, X and Y are the experimentally determined quantity. Write down this, X and Y are the experimentally determined quantity. Like I said, this may be equal to, may or may not be equal to their stoichiometric coefficient in a given balanced chemical reaction. Okay. Now, how this K is defined, like I said, it is a specific rate of the reaction. So why we are calling it as a specific rate of the reaction that you write down? K is, write down the rate constant is the rate of a reaction. The rate constant is the rate of a reaction when the concentration of all the reactant is taken as unity. When the concentration of all the reactant is taken as unity. Okay, so what happens if you see here, what happens if you put A and B is equals to 1? You'll get rate is nothing but K. Hence, K becomes the rate of the reaction. So that's why if the concentration is 1, K is nothing but the rate of the reaction. Hence, it is the specific rate of the reaction. Are you getting it? Right? Any doubt in this, guys?
No, sir.
Correct. Now, suppose if you write down this thing, again, the next term we are going to understand. Have you heard about order of the reaction?
Yes, sir.
Yes. So what is the order of the reaction? Suppose you have written the rate law expression this way. Order is the sum of the exponent of the concentration term in the rate law expression. Okay, for example, if the rate law expression is this for this reaction, then the order of this reaction will be x plus y. Clear? Okay, so write down the next heading, order. Write down, it is the sum of the exponent of concentration term in the rate law expression. So you see, for example, if I have taken this reaction, any random reaction, A plus B plus C gives product. Okay, so for this, the rate law expression RLE is equals to, rate is equals to, we can write according to just rate law that we have seen, the concentration of the reactant species to the power experimentally determined quantity like x, y, and z we can write. Again, x, y, and z, it can be equals to the stoichiometric coefficient here. Okay, so rate law expression is what? R is equals to the rate constant K, concentration of A to the power X, B to the power Y, and C to the power Z. So for this, the order of the reaction is what? It is represented by N, and N is equals to X plus Y plus C. This is clear? Yes, guys, did you understand this?
Yes, sir.
Yes, sir.
What is this X, Y, and Z? What is this X, Y, and Z? These are experimentally determined, right?
Yes, sir.
These are experimentally determined number. So order is also n experimental quantity. We cannot say the order of the reaction is this. Okay, it is an experimental quantity. If the rate law is given in the question, again, with reaction, you cannot write down the rate law because all these things are experimental. You never know what is the power of X, Y, and Z here. So you cannot write this by looking at the reaction, right? Because these numbers are experimentally determined. So if this rate law is not given in the question, you cannot find out the order of the reaction. Okay, if this is given, then whatever the power we have here, that we can add up, and that would be the order of the reaction. Got it? Yes. Any doubt, guys, still here? Did you understand
Yes, sir.
how was the lecture today? Was it tough, easy, moderate? Did you find the concept difficult?
Oh, so
It was fine.
Yes, sir.
Okay, fine. So we'll wind up, guys, the session here because order, then we have to start next class, various order of reaction, and based on order, we'll see the expression and some questions. Yeah.
Thank you, sir.
Thank you so much. Bye bye. Yeah.
thank you, sir.